Hi, today we're going to be talking about how we add vectors together to find a resultant. As we know, vectors have both size and direction, and they can be represented as arrows. The pointy end is called the head, and the other end is called the tail. Vectors can be added together. If they're in the same plane, they can be added together algebraically, but if they act in different planes, they must be added together using trig. Just like numbers or measurements, what you learned in algebra, you can't add different things together. You have always been told you can't add apples and oranges. But if you take two apples, or one apple plus one apple, you wind up with apples. Or centimeters plus centimeters gives you centimeters. You can't add quantities that aren't the same. You can't add a force and a velocity, or a velocity and an acceleration. You can only add velocities, or forces, or accelerations. For example, if you add a force with a force, you get force. If you add a velocity with a velocity, you get velocity. Now here's an example. If you walk 5 miles north and then walk 10 miles north, it should be apparent that the sum of those two motions will simply be 15 miles north. If we choose north as the positive direction, then we have a positive 5 plus a positive 10 gives us positive 15. If we walk 10 miles north and 15 miles south, however, then our total displacement will be a positive 10 plus a negative 15 because we've changed direction. And that's going to be a negative 5 miles or 5 miles south. We can't use positives and negatives if the directions are not parallel or opposite to each other, however. We can also add vector quantities using arrows or using the vectors. Vectors must always maintain their size and shape, but they can be moved around any place, and that's the key to using vectors. The vectors on the screen are all the same because they have the same length and the same direction. The important thing about adding vectors is when you add them together, they must be added tail to head. The sum of the vectors is also a vector and is called the resultant. It's the result of adding two vectors. It's always drawn from the tail of the first vector to the head of the last vector. Again, it's always drawn from the tail of the first vector to the head of the last. We have a 5-mile north trip can be added to a 15-mile north trip. So we have a 5-mile vector and a 15-mile vector. We add them together by placing the head to tail, and then we draw the resultant from the tail of the first to the head of the last. And so the result of adding the 5-mile trip to the 15-mile trip is going to be 20 miles north. If we have a 5-mile north trip added to a 15-mile south trip, we do the same thing. We add them tail to head, and the resultant gets drawn from the head of, or the tail of the first to the head of the last, and that gives us a 10-mile south vector. If the vectors do not act in the same plane, the rules still apply. If we have a 3-mile north trip added to a 4-mile east trip, they must be added tail to head. We can move them around as much as we want, as long as we don't change their size or direction. And so the resultant is drawn from the tail of the first to the head of the last. And you can see that the 3-mile north vector is still pointing north, the east vector is still pointing east. You can't just add these vectors together algebraically. You have to use trig to find the resultant. If drawn correctly, you're always going to get a right triangle. And of course, you can find the length of the resultant using the Pythagorean theorem. You'll also need to include direction, which will be an angle. We're going to be using the Greek letter theta for the symbol of the angle, and we're pretty much consistently going to be doing that. So in this case, if we have a 3-mile trip north and a 4-mile trip east, then the resultant of that is going to be not 7, but 5 miles, the hypotenuse of the triangle. The angle we're going to use for the direction is always going to be the angle between the two tails. Again, that's always going to be the angle between the two tails. So to find the angle, we're going to have to use the tangent function. From trig, remember that the tangent of an angle is equal to the opposite side divided by the adjacent side. On this diagram, that's going to be b divided by a. To find the angle, however, we need to use the inverse tangent function. So theta is going to be equal to the inverse tangent, and you can just use that inverse tangent key on your calculator, of b divided by a. We use the sides 4 and 3 because 4 is the opposite side, 3 is the adjacent side, and that gives us an angle of 53 degrees. Now it's extremely important that you make sure your calculator is in degree mode. Calculators have this nasty habit of flipping over to radians mode, and that's not going to be very helpful. So you always have to make sure your calculator is in the degrees mode. So now we're going to look specifically at adding projectile velocities, and that's going to be your activity for today. Remember that a projectile has a horizontal and vertical component to its total velocity at any point during its flight. The projectile has constant velocity in the horizontal direction, but accelerates in the vertical direction. The first step in solving these problems is to determine the horizontal and vertical velocities at a specific time using the correct equation. Then you draw vectors to symbolize each motion. It is helpful to always draw the horizontal first. That way you're always looking for the same angle. The angle will always be measured from horizontal. So let's say we have a projectile that's fired horizontally at a velocity of 15 meters per second. What will be its total velocity at 5 seconds? We're going to assume that g is 10 meters per second. So we draw the vectors, and we see that the horizontal component is going to be 15 meters per second. It has constant velocity, so it's always going to have a horizontal velocity of 15 meters per second. The vertical velocity at 5 seconds is going to be 50 meters per second. And that's using the equation VF equals VI plus AT. Since the initial velocity is always 0, that's simply going to be 10 times 5, or 50 meters per second. We can then determine the magnitude of the resultant using the Pythagorean theorem. C squared equals A squared plus B squared, or 15 squared plus 50 squared. And so we take the square root of that, and we wind up with 52 meters per second. And again, that's pretty simple trig. The last step, and the one that people forget about most often, is to find the angle. So we always find the angle using the inverse tangent function. So the inverse tangent is going to be 50 divided by 15, which is the opposite side divided by the adjacent side, and that's 73 degrees from horizontal. So hopefully this brief video will help you go through and work out the problems that you have in front of you. Also, you can check out the physics classroom, because they go through and do a pretty good job of talking about adding vectors. Thanks for watching.